This is the latest review that Math Zone has put together for Math 1108. And what we'll do here, again, as we've done in others, is to go over strategy. What do we need to know as background to be able to solve this? Now, as we look at that first example, this is solving an equation for the letter z. So we're going to combine like terms here, isolate the z's on one side, the numbers on the other, and then divide by whatever the coefficient, that is the number that's with the z, both sides. And that should give you the answer. All right, let's take a look at number 2. A rectangular-shaped fenced-in pasture is to have a perimeter of 900 yards. If the width must be 90 yards because of a building code, solve this equation to determine the length of the fenced-in pasture. Now here we have to do this multiplication, 180. Subtract 180 from both sides, and then divide by 2. Now for number 3, and I'll set this one up for you. If we have the square root of 75, what we want to do is simplify it by teasing apart the radicand into the largest perfect square factor. So as we look at this, can you see 25 times 3? When you do this multiplication, you get the square root of 75. But now I have under one radical sign the square root of 25. So we'll just do this one for you. This will become 5, the square root of 3. And we're not using a calculator. This is an exact answer. But it is irrational because the square root of 3 is irrational. All right, going on to number 4. Solve the linear equation and simplify your answer. Well, again, it only has one variable. So we need to distribute, clear parentheses, and then get all the y's over to one side, all the numbers over to the other, and then divide by the numerical coefficient, that is the number that's with the y, both sides. All right, number 5. Set up an equation for the following word problem and solve the equation. Let x be the unknown number. So 67 times the number, we're saying x is the number, minus 58 is equal to 36 less than the number. So the number would come first as an x here. There we go. Minus 36. Now after your initial setup, I would go back and read it again and see if in fact everything matches up. I believe that's good. And 67 times the number minus 58 is equal to 36 less than the number. So there's the number, 36 less than the number. Okay. All right, well, we'll raise it up now. For number 6 now, we're asked to consider this equation And notice it's in standard form. And as a review of that, that would be ax plus by equals c. And then we're asked to determine if this ordered pair, and then later this ordered pair, substituted for the x and y, make this equation true. So I'm assuming in Math Lab they will ask you a yes or no. Is this a solution, yes or no? All right, number 7, find the x and y intercept. Now, as soon as I heard something like that, or I hear something like that, I would make an x and y intercept t-chart. Because when x is 0, this is going to give you your y-intercept, 0, b. And when y is 0, this is going to give you your x-intercept, a, 0. So we just put a 0 now there for the x. So we're going to divide both sides now by 4, because this is 0. And that gives me a negative 15 fourths. Now the nice thing about our Hawk software, you just put that ordered pair in, and it plots it for you. Now if y is a 0 here, this 4y, 4 times 0 is 0. Now I divide both sides by 6. So let me just show you that. 15, and that's a negative 6. So I can take a 3 out of each one of these, and it becomes a negative divided by a negative is a positive now, and that will be 5/2. And that's the solution for that one. Now, for number 8, find the slope determined by these pairs. Well, we're using the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then we just put it in there. 8. 8 minus a minus 1 makes it a plus 1. Negative 5 minus 4. So here on the top, this is a 9. Here on the bottom, that's a negative 9. And a positive divided by a negative gives me then a slope of negative 1. Now, find the equation in slope-intercept form of a line with a given slope that passes through this point. It has this point here and this slope. So for this, I'd use the y equals mx plus b, which is the slope-intercept formula, and then I would start substituting. I know my slope is a negative 3/4. I know my x is a negative 4. I know my y is a 5. And what I don't know is what my b, my new b, would become. So notice here we have a negative times a negative, so that'll make this a positive. And then the 4's cancel out. So we're left with 5 equals 3 plus b. Transpose the 3 to this side, and we get a negative 3. So this is 2. So b equals 2. And now we're ready to write the equation. Y equals a negative 3/4 x. Students often forget to put that x in there. And my new b now is plus 2. Okay. Now for number 10, we're asked to look at this inequality, indicate whether the line will be solid or dashed, and then graph it. So as I look at this, this is only less than not less than or equal to. So less than is a dashed line. If it's less than or equal to, then that would be a solid line. So this is a dashed line, and they want us to graph it. So I'm going to use the x and y intercepts to get my points, because notice the 2 and the 3 go evenly into 12. So if x is 0, I'm going to divide the y by a 3, so that gives me a negative 4. And if y is 0 here, I'm going to divide both sides by 2. That will give me a negative 6. So I have my points. So now I'm going to raise it up a little bit here so I can see my graph better. And now I have my ordered pairs. So I need a 0, negative 4. So 0, negative 4 is 1, 2, 3, 4. That's my y-intercept. And then 1, 2, 3, 4, 5, 6. This is my x-intercept. And I said I needed a dashed line. And if we recall, we could use a here we see we have a positive y is less. Well, I've given my class the rule for this. See if I can match up where I was there. Here we go. We said when a positive y is less, we shade underneath. So we have region A and region B. We would shade region B. Now you could have also put a trial point here at the origin. By putting that into the original inequality, would that 0, 0 make that statement true? And the answer is no, it's false. So that indicates that would not be the shaded area. Okay, let's go on. Now, in something like this, where they want you to state the domain of a function, and this is just y equals negative 7x minus 6. And if you wanted to graph that very quickly, it would be a negative 6 down here. It's going over 1, up 7. So it would look like a line like that in a general way. So what would be the domain of that? Well, this line eventually would go to negative infinity out that way, and this one would go to positive infinity. So it would be all real numbers, or if they wanted it in interval notation, it would be from negative infinity to positive infinity. But I think they use that one where you need to check it. Okay, let's continue. Now they want us to simplify this expression. And let's set it up, and then I'll go through it with you, the detail. So I've just rewritten it here. And internally, we can do a little simplification first. We don't want negative exponents. So here, this negative 1, if I bring it down to the denominator here, it will become a positive 1 that I add to the 2. So let me do that. We're going to get rid of it up there. And this will become then a 3. We're just bringing that positive, that negative 1 down, make it a positive, and now we're just going to square the 3. That gives us a 9. we're going to square an x squared, so we multiply. That's x to the fourth. And we're going to square y to the third by multiplying, and that gives us y to the sixth. And that's the answer to that one here. Now, a lot of students I found have had errors in doing stuff like this. First of all, what are they asking you to do here? And the answer is subtract. Some of you think it's multiplication and will FOIL it or something. It's not. It's just subtraction. And how do we treat subtraction? Well, if there's a negative in front of a parenthesis, we just change signs. So this one will be a 8x squared positive, and this will be a negative 9. I'm sorry. This was positive. It's going to become negative, and this becomes a negative x. Now this first parenthesis, we don't do any changes. All we have to do is put it in like term columns. So this will be a plus 5x, and this is a negative 8. So now we're just adding them up. So this is a negative 8x squared. This is a negative 4x and a negative 8. So again, you want a strategy in which you can work things out like this. And a good one would be to get rid of the parentheses, change these signs, and then put them in like term columns and just do your addition. Remember, when you're adding or subtracting, the variables never change. Sometimes people would want to say, well, this is adding up x and x is x squared. No, 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 no. You don't do that. Okay. Now, here we want to multiply. So this will be x squared plus 3x plus 9. And then we're going to multiply it by x minus 3. So again, you could do it horizontally, taking the x and multiplying it by this, taking the negative 3 and multiplying it by this, and then grouping your like terms. But I like the idea of setting it up vertically, where you just multiply now negative 3 times a positive 9 is negative 27. This is going to be a negative 9x. And this is going to be a negative 3x squared. And you can check your work. So negative times a positive is negative, negative. That looks good. So now x times 9 is going to be a positive 9x. This times this is going to be a positive 3x squared. And this times this is going to be a x cubed. So now that I have them all in like term columns, I get x cubed. I almost missed that one. These two are going to just cancel out, minus 27. So again, you want a strategy. I think this is a good way. And then check your work. Watch the signs. Okay, here they want us to use the FOIL. So we have x squared plus 1 and 8x squared plus 7. So the FOIL, multiply these two, they give us 8x to the fourth. Do our outers, we get a plus 7x squared. Our inners plus 8x squared, and then our last plus 7. And then usually our middle terms are like terms that we group together. 8x to the fourth plus 15x squared plus 7. Now keep in mind that later they may ask us to take this trinomial and factor it into its original binomials that we're going to FOIL. That comes later. Now, as we look at this, this is one number, we'll call x, is 3 more than the other, x plus 3. So these are the two numbers here. Now, the difference between their squares is 51. So we have this squared, because this is the one number, the larger number, so we have x plus 3, the quantity squared. That's one number. That's the square of this larger number. And the difference between them, so this would be x squared equals 51. Not 53, 51. There you go. So, again, I could work this out for you, but let's do that. Let's say we're going to square this. So this is x to the second. Multiply these two together, then double it, plus 6x plus 9 minus x squared equals 51. Ooh, so this one works out nicely here. The x's are going to cancel out. And we get 6x. I'm going to transpose this number, this 9 here, to the other side where it becomes a negative 9. And then this is going to be 42. And then we divide both sides. X is 7. All right, let's see if I did that correctly, because I'll check my work here. Yes, so my two numbers are x, and then x plus 3 is 10. If I squared 10, I get 100. Square that, I get 49. And the difference is 51. So good. That one checked out nicely. Again, I don't have the answers. I'm just working these for strategy and some hints here. All right, now for number 17, again, many students were messing up on this because they had forgotten the technique. And the technique is you put each of these, 3x to the fourth plus 9x to the third plus 4 over your common denominator. X to the third, x to the third, x to the third. So now you're going to get 3 answers. Simplifying this, we get 3x. Simplifying this, we get 9. And this is as far as you can go here. And you get plus 4 over x to the third. And that would be the strategy for that one here. All right, this next one, we want to factor this, finding the greatest common monomial factor. So what can I take out of each one of these? Well, for the number part, nothing. Now I can take an x out of each one, and I can take a y out of each one. So here I'm left with 2y. Because if I distribute this, I get that. Plus 10, and the xy's we've taken out already, plus 11 x squared. And that is as far as we can go. And that looks like it. Okay. Completely factor the expression by grouping. All right, here's one we're going to do by grouping. Let me raise it up a little bit here. So the first thing I did was to kind of reorganize these 4 terms. So I would have here a common y, and a common factor of, let's say, 10. So I'm going to take out a negative 10y from these first two terms now. And this will give me a u minus 4a. Now from this second one, I can take out a 3r plus 3r, and I get u plus, oh, this had to be a plus over here. So I took out the negative, yeah. And this is going to be 4a here. All right. Yes, when I took out the negative 10, I had to change that sign. Sorry about that. But again, I'm doing this live, so to speak. So now my common binomial factor is going to be u plus 4a. And then I have here in this parenthesis a negative 10y plus 3r. And that looks good. Now, the trick part here, or the challenge, was you had to kind of line these up so you could take something out of two terms. And this was smaller, this was larger, smaller, larger, and it worked out. Okay, let's go on. All right, in number 20, we're about halfway through, and we are running, how many minutes are we? We are about 26 minutes. So I may divide this into two parts, so it's not quite so long. Well, each part not so long. So factor the given trinomial. Now, generally speaking, I haven't found any that were not factorable, so try not to use that except the super last resort. So I know I can take a 2 out of each one. I can take a 2x out of each one. So I take out the greatest common factor. And this will give me x squared minus 11x plus 30. Now remember, you can get partial credit for something just doing the top line. X. Factors of 30 that add up to 11, 6 and 5. Here, I got carried away. Minus and minus, FOIL it, checks out. That's a good one here. Okay, let's end this one, and this will be the first half.